Okay, so basically we understood what a simulation is. Simulation is basically an imitation of a real world system, and in that imitation version, in that fake version of a real world system, we can perform experiments with a lot less cost than what we had if we were to experiment on the real system, right? But still, even if the simulation approach or simulation methodology seems to be a very good methodology, according to Banks and Gibson, and by the way, Banks is the author of our textbook, according to Banks and Gibson, there are some situations where simulation is not an appropriate tool to use. So what are these? For example, if the problem can be solved by a common sense or analytical solution, if you can use a numerical integration to solve a problem. I mean, if you are taking manufacturing planning course, maybe you have heard about the Nives-Vendor problem or the Nives-Boy problem. It is called Nives-Boy or Nives-Vendor problem. Now, in many cases, the Nives-Vendor problem has an analytical solution. But you can also solve this problem with simulation methodology. You can create a fake version of this system and you can try different policies to optimize your periodic costs in the Nives-Vendor problem. But is it really necessary? No, because we already have a simple analytical method to solve this problem. Okay, therefore, simulation is a complex methodology for solving this problem. There is already an analytical solution. And maybe in some cases, making experiments on the real system itself, the original system itself, is going to be less expensive. Okay, as I have said, simulation takes some time. It's a project. It involves many people into it, or it involves some costs as well. I mean, we are talking about constructing a new door to a warehouse here. And of course, it is a very expensive investment. However, if the change that we are going to make on the system is not very expensive, in fact, less expensive than creating a simulation project, why should we use a simulation methodology to solve the problem again? So again, the simulation would not be an appropriate tool to use here. And if the costs exceed expected savings after the simulation project, again, we should not use as a solution methodology. Okay, so even if you are making experiments on the imitation or the model of the original system, there will be some costs associated to creation of this model, right? So you are going to create it, you are going to develop it, then you are going to run some experiments on it, and you are going to spend some time and maybe some workforce as well on the creation of the simulation model. So experts are going to create this simulation model, and it is going to create some costs as well. Now, after solving the problem with a simulation project, there may be some expected costs based on the improvements that you are going to propose for the original system. Now, you also need to make a prediction of these expected savings or expected profits that you are going to have in the end of the simulation project. If these expected savings are less than the costs that will be created by applying simulation, again, simulation would not be an appropriate tool. And sometimes there may not be enough time or enough human resources, okay, or enough knowledge to develop a simulation project. And again, you should not implement simulation in this case. Now, you can create a simulation model, but the model may not really imitate the original system. I mean, even though you make experiments on that model, I mean, it is not fully representing the original system. How can you trust the results that you obtain from that model? So what I'm mentioning about here is the model that you have created, it may not be a valid model of the original system. And in that case, we say that when the simulation model is not validated, you should not trust on the results that you obtain from that simulation model. And again, it is not going to be an appropriate tool to use here. And sometimes the system behavior, the original system behavior may be too complex to model. Okay, so it may be very, very complex to model. So in that case, again, you cannot create a simulation model of that system. Okay, so these are the cases when simulation is not appropriate.